In the previous videos, we have designed a simple UI in Jetpack Compose using layout capabilities like column, row, box, spacer, and some modifiers. But what if we want to design our UI in a specific way that needs even more control and a specific alignment and a specific chaining and positioning on the screen? How do we do that? Fortunately, Jetpack Compose also has support for constraint layout. If you are familiar with constraint layout from Android views, you know that constraint layout is a mechanism to put items in relation to each other on the screen and in specific and complex alignment. If we have some complex alignment, complex layout that we want to design, we can use constraint layout. And in order to use Jetpack Compose with constraint layout, first we need to add constraint layout artifact to our list of dependencies in our Gradle files. So I open my build.gradle file, I press Ctrl Shift and N to search for build.gradle. I have already searched it. So build.gradle from the app module, the file that contains our dependencies. Following our implementation for Jetpack Compose dependencies, I add another line of implementation, AndroidX.constraintLayout and ConstraintLayout Compose. This is the type of artifact that we need from the constraint layout library in order to add support for constraint layout in Jetpack Compose UI creation. So note that it has its special versioning. It's not the same as Compose version, so we cannot use Compose version. Instead, we can use the trick that we talked about in some previous video, that we can ask Android Studio to help us with the version by giving it a minimum version first, like 1.0.0 alpha 01, and then Android Studio will tell us that there's a newer version than this one. I press Alt and return, and it tells me to change it to 1.0.0 alpha 3, and I accept, and now we have the latest version of this artifact added to our list of dependencies. I press sync now. I don't need to do that. It has already been added actually. If it's the first time that you are adding this dependency to your project, you need to press sync now. That will appear somewhere around here on the toolbar. And after that, you will be able to use constraint layout in your application. So to use it, let's go back to our main activity. And what I'm going to do, I'm going to design the same UI, this time using constraint layout. So I create a composable. Let's use templates by typing comp and then pressing enter. And I'm gonna call it item screen or constraint item screen, because it is designed with the help of constraint layout. And I will have another preview that will preview this one. So I type prev and press enter, and then call it preview constraint item screen. And then inside it, I make a call to constraint item screen. Okay. Note that now, because we have two previews, we will have two previews on the right side of the screen. So the first step to using constraint layout is calling this composable, constraint layout. and we will need to import it from the compose module of constraint layout library. So constraint layout, I imported androidx.constraintlayout.compose. I select the first one, and now we have it here. Then we define our items and their constraints. So the first step is to define the items references, or references to the items or UI components that we will have on our screen. So the main ones, the main components that we will have, because I don't want to make it very complicated, is this box around here, and this text field, and these two buttons. We can also add the spacers, but it will make it complicated, so I skip it. I create a variable val for reference, as a reference to this box, so I call it box, and then create ref. This will create a reference for the box that I can later use when constraining this box. And the next one is the text field. Val input, this is a text input, create ref, and the next one is the increase button and decrease button. So val increase and val decrease, both of them create ref, create a reference. So we have 4 lines just for creating references to our components, but Kotlin has a way of doing that in just a single line, and it is called destructuring assignment. You can actually create all these references in just one line. So I'm gonna do that and show how easy and useful it is. I specify, in addition to the box, I specify input, increase and decrease here, and instead of create ref, I call create refs. And to have all of them get value, I put all of them inside brackets, parentheses, and I remove the other lines that used to define them individually. And now we have 4 references to the components of box input, increase and decrease. So I remove these lines, we don't need them anymore. Next, I'm going to use these items. So for the box, I'm gonna copy it from the above one. This box is the parent box with its children. So I copy the whole box and I paste it here. We don't have the weight anymore because weight doesn't apply in the current scope. So I remove weight modifier from this part. And because I'm going to constrain the box to the parent, I'll call this modifier constrain as, and let's not forget to put a pair of parentheses in front of it and name the reference. First we name the reference for the box. The reference is called box, and inside its body we will define its specific constraints for this component. I copy the other items as well, the buttons and also the text field. So I copy this line, outline the text field, put it after the box. And also we have these two buttons. So button, the first button increase, and the second button. I'm gonna copy both. Copy and paste it after outline text field. Because we are working inside the scope of a constraint layout, we don't need to respect the order. The order doesn't matter anymore because now we have constraint, and these constraints are the things that define how we order and how we arrange the items on our screen. Again, the weight modifier doesn't apply inside a constraint layout scope, so I remove it for both. Alright, let's give constraints to our text field and the buttons. So for the modifier, I put the modifier in a separate line to make it easier to read. Constrain as. What was the reference for our outline text field? It was called input. And let's open the body of our constraint definition. And let's do the same for our buttons. Constrain as, and for the first button it was called increase, the body of the constraint definition, and the second one was called decrease. Constrain as decrease and its body. Before we actually create the constraints, let's see what we are going to do. I'm going to constrain the big box, the father box, to the parent's top and to the parent's start and to the parent's end. And I'm going to constrain the text field's top to the box's bottom. And then the increase button's start to the parent's start, and the decrease button's start to the increase button's end, and also the decrease button's end to the parent's end. Let's do that. First, starting with the box, with the parent box. Where were we? We were here, constraining the box. I say do this for the box. Chain its start link to parent start, and chain its top to the parent's top, and chain its end to the parent's end. Okay, now we move on to the next composable, the text field. And for the text field, I constrain its top to the bottom of the box. So I say top link to box bottom. And also, let's not forget its start link to parent start, and its end to the parent's end. This will make it central when we look at it horizontally and give it a better view. And now it's time for the buttons to be constrained. And for the first button, increase, I constrain its start link to parent start, and its top, it's very important, this part, link to the input component's bottom. Input here is a reference that we can call, and we can use its bottom and start and other components. That's enough for this actually. For the first button, it's enough. Let's go to the next button, and for the decrease button, I constrain its start, link to increase button's end, and also its top, link to increase button's top. This will align the two buttons together. We could also have chained its top to the input references bottom. Okay, let's refresh our preview and see if it is indeed what we wanted. Let's scroll down because our preview for the constraint layout will appear down below. Okay, we have some constraints applied, but it's not actually exactly how we wished it to be. One of the reasons is that we didn't give a size to our constraint layout. So actually, let's do that. Let's give our constraint layout a maximum size. If you remember, for our column in the above preview, we actually had a maximum size. You can see that here. We used a modifier fill max height. So I do that for my constraint layout as well. Modifier and modifier dot fill max height. And I have the maximum height now for my constraint layout. Let's do a refresh. Another reason that we don't have exactly the same UI that we designed using columns is that in the columns case, we had weights. We could use weights, but we don't have that in constraint layout. In fact, as I mentioned, constraint layout is a layout that allows you to do specific positioning of items with in relation to each other. So one item's bottom goes to the top of the other, and one component's start is chained to another component's end, and so on and so forth. Anyways, to make it look more beautiful than this, I'm gonna make some small changes. For example, here for the big box, I'm gonna give it a height. I'm gonna give it a bigger height actually, because it already has a height that was formerly, in the case of the columns, shadowed by the fact that we were using weights, and the weight preceded that. But now, in the case of constraint layout, we can give it a constant height, like for example 500 depth. And also for the buttons, we can constrain them, constrain the decrease button's end to the end of its parent, and it should look more beautiful than this. And also their bottom to the parent's bottom. You can play around with these constraints to achieve the positioning and the layout that you want. The point is that constraint layout gives you a lot of flexibility to create complex UI components in your Jetpack Compose UI. So for the decrease button, I add end link to parent end, and also its bottom link to parent bottom. Refresh the UI. It's still refreshing. It's not actually exactly what we hoped for. As you can see, I can play around with the increase button as well. For the increase button, bottom link to parent's bottom. Refresh. It is refreshing yet. Okay, there must be something wrong. Actually, I need to constrain its bottom to the bottom of increase, the decrease button's bottom to increase button's bottom. So decrease, here we are, decrease, and bottom link to increase. Come on, show me the preview. There we go. It's better now. Okay, although we didn't exactly create the same UI that we had here in the above section in our second preview, we were able to use constraints to constrain our items and our UI components in a specific way. And this shows us that constraint layout can be used for complex constraints and chaining of items with relation to each other and the parent when we need to. But in case you don't need to create complex UIs, you don't need to probably create your UIs using constraint layout, because it might make it a little bit overwhelming and difficult. If you are creating straightforward UIs, you can just comfortably go ahead with columns and rows and nesting of UIs like columns and rows. But anyways, we have this UI created using constraint layout. Note that the big box that we used was just used as a unit, and the constraint layout had nothing to do with the items and with the children of the big box. Those were positioned using its own mechanism for alignment that we designed earlier. But there's a property of constraint layout that we can use to help our buttons have bigger width and use the constraints that they have and fill their width to the maximum constraint that is allowed for them. So let me show that in action. First, I'm going to constrain the decrease button's end to the parent's end and make sure that it is already that way, and link to parent end, and remove its initial constraint, the start constraint, from the increase end. And the property that I'm going to use to allow this button to fill in the maximum allowed width by the constraint, I'm gonna use width equals dimension dot fill to constraints. And I'm gonna use the same property for the increase button as well. And now if I refresh the UI, I should see a better UI for these two buttons. In fact, to help these buttons fill in half of the screen width, I'm going to chain them to each other. So I'm gonna chain the end of increase to start of decrease and start of decrease to end of increase. So let's start with increase, and I'm going to add its start link to increase and decrease start this should be and link to decrease start. Sorry, this is decrease. I'm gonna do this. I'm gonna copy this line for increase. I cut and pasted here and link to increase start. So end of increase linked to start of decrease. And I'm gonna do that the other way around. So for decrease, start link to increase end. Okay, let's refresh the UI and see the result. There we go. You see that our buttons now take half of the screen width each. By specifying this kind of chaining them to each other, and also specifying their width as fill to constraints. So that's it for constraint layout in Compose. I hope that you liked this video.